So now we have 9-6A. So we're going to kind of move our focus a little bit to solving rational equations. And our objective is just that. We are going to solve rational equations. And we can find this on page 514 and 515 in your book. So the first type of problem that we have is 1 over 5x equals 1 over 9x. So what I would do in this case, this is like a proportion, okay, this type of problem. So anytime you just have one fraction equaling another, you can treat it like a proportion. So you can multiply diagonally. So 5x times 1 is 5x. 9x times 1 is 9x. So I would want to, because I have variables, I'd want to move them all to one side. And so then I get negative 4x equals 0 if I subtract that 9x. And then if I divide by negative 4, I get x equals 0. Now the one thing is, whenever you solve, you always want to check and make sure that your answer can work in the denominator. If your answer makes the denominator 0, you cannot use it, okay? So I am going to check, and if, like, I'll check with that 1 over 5x. So if I put in that 0, I get 1 over 0, which is undefined. Therefore, x cannot equal 0, and I have no solution. Okay, so really in this case, whenever you solve rational equations, you always want to make sure that your answer can work in the denominator, okay, and it doesn't make it 0. Let's look at our second problem. I have 3 over x equals 12 over x plus 7. So again, this is a fraction equaling a fraction. So I can treat it as a proportion. So I could do x times 12, which is 12x. And I can do 3 times the quantity of x plus 7. So I'm going to need to distribute. So that's going to be 3x plus 21. Okay, so I had to do 3 times x plus 7, and I needed to distribute that. And so again, just like the other one, I want to get my variables to one side and my constants to another. So I'm going to subtract the 3x. And so I get 9x equals 21. I'm going to divide by 9. And then I get x equals 7/3 because I do need to reduce that 21 over 9. I do just want to check and make sure that 7/3, if I substitute it in, won't get me 0. And it won't in this case, so we're good. That means that we're good to go. Okay, it is truly, it's not, I don't want to use the term rare. I mean, every now and again you will get something like our first one with a no solution, but a lot of times they do end up working out because they don't make the denominator 0. You always want to double check it, but a lot of times it should end up working. Let's look at number 3. So I have x plus, plus 6 over x equals negative 5. So similarly to our complex fractions, I want to write all of these as fractions. So I want all of them to have a denominator. Now this is not written like a proportion. It's not just a fraction equaling another fraction. So because of that, I need to find the least common multiple. Okay, so looking at 1x and 1, my least common multiple is going to be x. So that means that next to each of these, I'm going to have to multiply an x minus 1. An x over 1. Why did I say x minus 1? So this I bring down, and I needed to multiply by x over 1. I don't know why I keep saying x minus 1. And then plus, and then I'll have my x over 1 times my 6 over x equals, and then again my x over 1 times, and then that's going to be the negative 5 over 1. And so now I can go about here, so I'm going to multiply these together. So I'm going to get an x squared. Here the x's can eliminate, so I'm just left with a 6. And then that equals, and then over here, there's nothing that I can diagonally reduce, so I'm just left with a negative 5x. Now, because I have a quadratic, a linear, and a constant, I'm going to need to set this equal to 0 and solve, and like factor to solve. So I'm going to leave my x squared on the left. I'm going to move my 5x over, and then I have plus 6 equals 0. So I am going to need to factor. So the x squared plus 5x plus 6 equals 0. You'd want to do your x method, so I'd get x plus 3 times x plus 2. And when I go to solve, I'll get x equals negative 3 and negative 2. And so for that, that actually all works out, because if I go back to the original, the only variable I have there is in the denominator, and that's just an x. Well, if I put in a negative 3 or a negative 2, that works out. So we're all good there. Good to go. I've got 2 more problems that I'll go ahead and do in the next video to kind of keep these a little bit shorter.